Hey guys, so this is the last section of chapter 3, and we're going to be using synthetic division to find the zeros of polynomials, okay? So what does it mean? Remember when we were doing synthetic division today and yesterday, and we got a remainder of 0 sometimes, right? We got a 0 in that remainder column. So that actually means when your remainder is 0, okay, that you have just found an x-intercept, okay? Or you have just found a 0 of that polynomial, okay? Or you have just found a solution for that polynomial, okay? So all three of those things mean exactly the same thing, x-intercept, solution, or 0. Okay, so let me show you kind of how this works. Okay, so there's several types of problems they can give you. One type of problem they can give you is to say, find all of the zeros. Now, keyword here is all. Okay, that means you're going to find real and imaginary zeros. Okay, if they give you one of the zeros. Now look, if they're saying that x equals 2 is a 0, this means that when you plug this into synthetic division, you should get a remainder equal to 0. Okay, so that should be like the one thing you should check when you're doing this problem. If you plug in 2 into synthetic division and you don't get a remainder of 0, that means you did something wrong, or the number they gave you was wrong. Okay, so let's go ahead and do that. So they're saying that x equals 2 is a 0. So I'm going to go ahead and plug 2 into my little box. Okay, now notice I did not change the sign, because if they gave it to me in this form, like x minus 2, then I would change the sign. But they already changed it for me. They said x equals 2. Okay, so let's go ahead and look at all the coefficients. So first, double check to make sure that you're not skipping anything. I have 4, 3, 2, 1, and 0. So I'm all good. So my coefficients are 1, -1, 1, -3, and -6. And again, that's just taking the numbers in front of each one, okay? Let's go ahead and draw our remainder column, and then let's get going, okay? So remember, when we're doing synthetic division, we're going to bring down the 1, and then we're going to multiply that 1 by this 2. So 2 times 1 is 2. We're going to add that up. -1 plus 2 is 1. We're going to multiply that 1 again by this 2. 2 times 1 is 2. Add that up. 1 plus 2 is 3. Again, multiply that 3 by this 2. 2 times 3 is 6. -3 plus 6 is 3. Multiply by 2 again. 2 times 3 is 6. And -6 plus 6 is 0. Now, you guys, look, I knew that. I knew that I was going to get a remainder of 0. I have to get that. If you don't get that, that means you did something wrong. Go back and do it again, okay? Now look, I need to figure out, like, what else is what are the other zeros gonna be? So I know that when I plug in x equals 2 into here, it's gonna give me a 0. But let's see if I can find the other solutions, because there should technically be 4, right? So here's how I'm gonna do it. Look, this is your remainder, this is your constant, this is your x, this is your x squared, this is your x cubed. So I'm gonna go ahead and write this as a polynomial, and I'm gonna try to solve it. So look, I have x cubed plus x squared plus 3x plus 3, and I'm going to try to solve that equation if it equals 0. So remember, if you have 4 terms, grouping's your best bet. So let's factor out an x squared. That leaves me with an x plus 1. Let's factor out a 3. That again leaves me with an x plus 1. Okay, and then by grouping, you guys, again, remember the stuff in the parentheses should be the same. So that's going to be your greatest common factor. If I pull out that x plus 1, I'm going to be left with x plus 3 equals 0. Okay, now setting both of these guys equal to 0, I have x plus 1 equals 0, which gives me that x equals -1 is another solution. And then I have x squared plus 3 equals 0. Let me finish solving that over here. If you subtract 3 from both sides, you're going to get x squared equals -3. And you guys, great review here, right? Remember, it said find all the solutions. So we just can't say, hey, you can't do that. That doesn't work. It does work. It's imaginary, right? So you're going to get x equals, don't forget your plus or minus. And remember, the negative comes out of a square root as an I. So you have I rad 3. Okay, so look, if you wanted to list all of the solutions, okay, so all the zeros are the following, okay? You're going to have x equals 2. That's the one they gave me. X equals -1. and then you have plus or minus I rad 3. And look, there should be 4, right? The degree of my polynomial was 4, so there are 4 solutions. Isn't that kind of cool? And you guys might be wondering, like, what would we do if we didn't know that x equals 2 was a 0? We're going to get to that, okay? It's called the rational roots test. It's kind of cool. All right, let's try another one. And you guys, if you feel like, hey, I can do this, go ahead and try number 2 and see if you can do it on your own. If not, then just kind of follow along with me. All right, so this guy, okay, again, I'm going to do synthetic division. It asks for all the zeros again. So it told me that x equals 1 is one of the solutions. So I'm going to put that in here. And then again, I'm going to do synthetic division. Double check to make sure you're not missing a term here, right? It goes 3, 2, 1, 0, so we're all good. Coefficients are 2, 3, -8, and 3. Okay, and then let's go ahead and finish this up. So I'm going to bring down my 2. Then I'm going to multiply. Remember, what are we multiplying? We're multiplying by this number here. So 1 times 2 is 2. Add them up. 3 plus 2 is 5. And multiply. 5 times 1 is 5. Add them up. -8 plus 5 is -3. And then remember, my remainder better equal 0 because it told me that it's a solution. So let's hope. 1 times -3 is -3. And look at that. 3 minus 3 is 0. So I know I did it right up to this point. Okay. So again, break it down and then write down the polynomial that you have left over. You have a remainder, constant, x, and an x squared. So the polynomial that remains to be solved is 2x squared plus 5x minus 3 equals 0. Now, how do we solve something like that? So you guys, this is a quadratic because the degree is 2. So there's 3 ways we can go about this, and let's just review them. This is great review for your final. You can either factor, which is definitely the first thing you should try. Then you can maybe complete the square, or last resort, you can use the quadratic formula, okay? I'm going to try to factor. I see 3 terms with a number in front. This means this is going to be the big star. Okay, so I have 2 times -3 is -6. Add to make 5. That would give me -3. Oh, no. My gosh. Not -3, -2. That won't work. See how easy it is to make that mistake. Let's try 6 and -1. Okay, and then your leading coefficient's 2, so I'm going to divide by 2. This guy reduces to a 3. And -1/2 doesn't reduce anymore. So this guy then factors to x plus 3, x minus 1/2 equals 0. And setting both of these equal to 0, you're going to get x equals -3. And you're going to get x equals 1/2. So again, you guys, the question was find all of the zeros. There should be 3 of them because the degree was 3. So all the zeros, make sure you make that list so you have all of them in there. You have x equals 1. That's the one they gave me. Okay, then you have x equals -3 and x equals 1/2. So in this case, that one was kind of easier, right? None of those imaginary things, all right? Okay, now this gets a little bit trickier, okay? So you guys, this is kind of the difference between regular Algebra 2 trig and honors is that you guys get to do stuff that's a little bit more fun, okay? Or harder, meaning fun. Okay, so this one says, same question. Again, find all the zeros given that 3i is a 0. So they're telling you that one of the imaginary that one of the zeros is an imaginary number. Now, you guys, something you need to know in this, and put this up here in a star, okay, or in a bubble or something to remind yourself, okay? Imaginary zeros always come, oh my gosh, this thing's driving me crazy. They always come in pairs. Okay, so what does that mean? Okay, what that means is that if x equals 3i is a 0, then so is -3i. Okay, so one's always positive, one's always negative. Now, you guys, this only works for imaginary zeros. If it's at x equals 3, then that's it. Okay, so here's what I'm going to do. And you guys, this is kind of fun stuff. I'm going to show you something really cool. So let's go ahead and start with this. I know that 3i is a solution to this equation. So I'm going to put 3i in my little box here. Okay, now what's left over? Well, let's check out our degrees here really fast, right? I have 3, 2, 1, 0. Nothing's missing, so I'm good to go. So my coefficients are 1, 1, 9, and 9. Now look, you guys, this is going to be a little bit harder because of the i's, okay? But you can do it, okay? Remember, we better get that the remainder here equals 0. If you do not, you did it wrong. You need to go back and do it again, okay? So let's go ahead and give this a shot. So I'm going to bring down the 1, nothing hard there, right? Now I need to multiply the 3i times the 1. Well, that's not hard. 1 times 3i is still 3i, okay? No biggie, okay? Now let's add them up. What is 1 plus 3i? Can't really add those together, right? So 1 plus 3i is just going to be 1 plus 3i. Now I know that's kind of freaky, but it is what it is. Okay, now I need to multiply these two guys together. I need to multiply 3i times 1 plus 3i. Now because it's getting a little bit more complicated, I'm going to do it on the side here. Look, 3i times 1 plus 3i. It's just an easy distribute, but it is kind of worth it to write it out. So you have 3i plus, and this becomes 9i squared. You guys, this is great review of imaginary numbers. Remember, I squared equals -1. So this is really 3i plus 9 times -1, which is really 3i minus 9. Okay, so all of that work to get 3i minus 9 here. Okay, now this is kind of nice because look what happens next. If I add those up, these 9's cancel out, leaving just the 3i, right? And now I need to multiply this 3i times this 3i. Well, let's do it on the side here. What is 3i times 3i? Well, again, that's 9i squared. Remember, I squared is -1. So that's really -9. And check that out. 9 minus 9 is indeed a big fat 0. Okay, now look, got a little problem here, right? How the heck do you write that as a polynomial? Like, I wouldn't know if I wrote that as like x squared plus 1 plus 3i x plus 3i equals 0. I don't know how to solve that, right? I don't want to factor that. So here's what I'm going to do, and this is a really cool trick, okay? So look, I know that imaginary zeros always come in pairs. I know that if I plug in 3i, I'm going to get a remainder of 0. But because they come in pairs, I know that if I plug in -3i, it's also going to work, okay? So here's what I'm going to do. Instead of starting over, I'm going to draw a new box right here, okay? And I'm going to put this other 0 in there, this -3i. And I'm going to go ahead and keep breaking down this polynomial until it becomes something that I can actually factor or solve. Okay, so watch this, okay? I'm going to extend this down a little bit more. Okay, oh, no, I'm not. I lied, sorry. Okay, my new remainder this time, I'm sorry. This was your old remainder. Your new remainder is going to come from here. Okay, so check this out. So basically, we don't need this guy anymore. Okay, so doing this again, okay, I'm going to bring down this one. Okay, -3i times 1 is -3i. Now, what is 1 plus 3i minus 3i? Look, these 3i's cancel out. It's just a 1. Do you see how simple that is? Okay, and then if I do it one more time, -3i times 1 is -3i, and 3i minus 3i is 0. But we knew we had to get a remainder of 0 because we knew that that was a solution to my equation. Okay, now what is the polynomial that I have left over? So look, this is your remainder, this is your x, no, I'm having real issues here. This is your constant and this is your x. So this is a very basic polynomial. It's just x plus 1 equals 0. And how do you solve that? You better know. You subtract 1 from both sides, so you get x equals -1. So look, if I wanted to answer the question here, what are all the zeros? Okay, well, here we go. It's x equals 3i. That's the one they gave me. It's x equals -3i. How did I know it's negative? Because they always come in pairs, okay? And then it's x equals -1, the one that I found. I found 3 zeros. The degree of this polynomial was 3. I need to have the same number of zeros as the degree of the polynomial. All right? Super cool. Okay, let's do one more. Okay, now you guys, this one's really awful, okay? So take a deep breath, okay? We'll just do this together, all right? So look, this time they told me that 1 plus 3i is a 0. Now look, that again is an imaginary number. Remember, they come in pairs. So if 1 plus 3i is a 0, that means x equals 1 minus 3i is also a 0. Whoops, I can't spell. Okay, that's really driving me nuts. Sorry. Now, you guys, this is like evil, okay? So here we go. In my little box, I'm going to put this 1 plus 3i, which really turns this into a nightmare, but it's okay. We're going to do it together, all right? Now, let's look at our coefficients. Again, make sure that you're not missing any variables, right? You have an x to the 4th, an x to the 3rd, x squared, 1, and a 0. So I have 4, 3, 2, 1, 0. There's nothing missing. I'm all good. Okay, so let's write down our coefficients. And you guys, for this one, I suggest that you really write it out big, okay, because there's going to be a lot of stuff going on, okay? So my first coefficient is a 1. My next one is a negative 3. Do you see how I'm spacing it out a lot? Please do that on your paper as well. It's going to get really crunched together if you don't. And then a 6, and then a 2, and then a negative 60. Now look, it's kind of scary, I know, but one thing I do know is this has to be a 0, okay? The remainder here has to equal 0 because it told me that this was a 0. It was a solution, okay? So that's a great way to check that you did it right. Okay, so let's go ahead and do this. We're going to do it super slow, all right? So bring down the 1. Okay, that was easy, right? Multiplying by 1 is easy. So if we do 1 plus 3i times 1, right? 1 plus 3i times 1 is just 1 plus 3i. Okay, now it's really bugging me that I circled those, so let's uncircle them. All right, now here's where it gets interesting, guys. Ready? I really wish those i's weren't there, but they're going to be. If I add this up, I can only add up the real part. So negative 3 plus 1, that's negative 2, and then I'm still going to have that plus 3i. Okay, now here's where it gets really gross. So look, I need to multiply the 1 plus 3i times negative 2 plus 3i. I'm going to go ahead and do that on the side because that's just kind of crazy. So let's do it right here. Let's do 1 plus 3i times negative 2 plus 3i. Let's take it nice and slow, okay? So 1 times negative 2, that's negative 2. 1 times 3i is 3i. Then you have 3i times negative 2, which is negative 6i. And 3i times 3i, now you guys, we've done that already. That's 9i squared, which is really negative 9 because the I squared equals negative 1. Now, combining some like terms here, we have the negative 2 and the negative 9, which gives us negative 11. And then 3 minus 6i, that's going to give me negative 3i. Okay, yeah, that was gross. So you have negative 11 minus 3i goes up here. Now let's do it again. I promise it's going to get easier. So again, I can only combine the real terms here. So 6 minus 11, that's negative 5. And then I'm still going to have that minus 3i. Okay, this is so awful, I know. Now look, you have to now multiply 1 plus 3i times negative 5 minus 3i. Again, I suggest doing it on the side just so you don't make mistakes. So now I have to do 1 plus 3i times negative 5 minus 3i. All right, so let's do this. So 1 times negative 5 is negative 5. 1 times negative 3i is negative 3i. 3i times negative 5 is negative 15i. And then 3i times negative 3i is negative 9i squared. I'm going to write that one out because then that's going to become, let's see, that's negative 5. Combining these together is negative 18i. But you guys, this is really negative 9 times negative 1, which becomes a positive 9, okay? And then adding those real terms together, negative 5 plus 9, that gives you 4 minus 18i. All right, so let's put that in there. 4 minus 18i. Now, at this point, you might be thinking, Ms. Cruzy, I'm so done with this problem. Yeah, I kind of am too, but we've got to finish it up, okay? So again, all you can do is add these real terms. So 2 plus 4 is 6. So now I have 6 minus 18i. Now, you guys, look, you might be thinking, Cruzy, there's no way that's going to come out to be 60. But I think it will, okay? Because I have faith in math, okay? So let's multiply 1 plus 3i times 6 minus 18i. Okay, I'm going to do it... Oh my gosh, I'm going to do it right here. So I'm going to have 1 plus 3i times 6 minus 18i. I'm going to cross my fingers here that it works out. So 1 times 6 is 6. 1 times negative 18i is negative 18i. 3i times 6 is positive 18i. And then you guys, 3i times negative 18. So what's 18 times 3? I have no idea. It's 54, okay? So it's going to be negative 54i squared. Now look, something super interesting happens here. Look, these guys cancel out, right? And then you're left with 6 minus 54 times I squared, which is really negative 1. So you guys, this really equals 6 plus 54, which is 60. Now look, that is great news because negative 60 plus 60 is 0. So now you can kind of take a deep breath and go, oh my gosh, I did it right. Now look, we have to do this one more time, but I promise you, the second time around, it's really, really easy, okay? So look, you cannot turn this into a polynomial, like no way. There's way too many i's, I would not know what to do with it. So what am I gonna do? Okay, well, I'm gonna go back up to the original problem. I just used the fact that 1 plus 3i is a 0. Now I'm going to use the fact that I know 1 minus 3i is also another 0. So look, over here in a new little box, I'm going to put 1 minus 3i. Now please, before you turn off the video and say, I'm not doing this, it's too much, I promise that it's so much easier the second time. Watch this. Draw a new remainder line because we don't need that guy anymore. I promise you, you've got to trust me. Look, now what's going to happen? Ooh, let's just keep doing it in black. Okay, so if I bring down the 1, okay, 1 times 1 minus 3i is the same thing. It's just 1 minus 3i. Look what happened. I can combine the real parts. Negative 2 plus 1 is negative 1. And then these guys cancel out. You guys, the second time around that you do it, that always happens, okay? Now, let's multiply negative 1 times 1 minus 3i. Well, that's just changing the signs, right? That's negative 1 plus 3i. And again, check this out. These cancel out again. Negative 5 minus 1, that's negative 6. And then let's go ahead and multiply negative 6 times 1 minus 3i. That's just a regular distribution, right? So it's going to be negative 6 plus 18i. And notice, look, cancel, 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 big fat 0. But we knew that. We knew we had to get a remainder of 0 because we knew that 1 minus 3i was a solution, okay? Now, this I can turn into a polynomial that I can work with, right? So this is your remainder, this is your constant, this is your x, and this is your x squared. So my new polynomial is x squared minus x minus 6 equals 0. And you guys, that is definitely something I can factor, right? This is going to be x minus 3 times x plus 2 equals 0, giving you that x equals 3 and x equals negative 2 for your solution, okay? Now look, if you want to write out, remember the question was find all the zeros, okay? A lot of people just end up writing these two answers down. I need 4 answers, right? The degree here was 4, so I need 4 answers. If you just wrote these two down, that's only 2. Okay, so what are all the zeros? Well, it's x equals the original one, which was 1 plus 3i. X also equals its conjugate. Remember, they come in pairs, 1 minus 3i. And then we knew that x equals 3 and x equals negative 2. So I have 1, 2, 3, 4 zeros. All right, so always make sure that the degree and the number of zeros is matching up. If not, that means you left something out. So you guys, I hope you enjoyed that. Like, this is really powerful stuff. And then you guys, I'm going to show you the rational roots theorem later, and then we are all done. I'm so excited. All right, have a good weekend. I'll see you guys on Monday or Tuesday. Okay.